Okay, today we're going to talk about Chapter 3, Section 2. We're going to go further what we talked about in Section 3.1. Section 3.1, we talked about alternate interior angles, alternate exterior angles, same side interior angles, and corresponding angles. Now we're going to take it one step further. Now we mentioned the transversal intersecting two lines to form those relationships. And when it did, when the transversal intersected the two lines, it formed 8 pairs or 8 angles. We're going to take it one step further. Today, we're going to focus on what happens if those two lines are parallel. That's the step for today. All right, here are the standards we're focusing on. And let's first start with postulate 3-1. It's the same side interior angles postulate. It says theorem here, but it's supposed to be postulate. So let's change that. Now remember, we learned in Chapter 2 that the postulate is a statement that we assume to be true but cannot prove. And another word for that is axiom. A theorem, on the other hand, is a statement that can be proven. We'll do those a little bit later on. All right. Postulate 3.1, the same side interior angles postulate, says that if A is parallel to B. Now, how do we know that A is parallel to B? Well, it says there, but also, I want you to look at this right there. You will see these little pink marks right there. Anytime you see marks like that on two pairs of lines, it tells you that they're parallel. So that's going to be the same for each of these diagrams throughout the lesson. All right. Now we know that angle 4 and angle 6, their measures add up to 180 because same side interior angles, as long as the two lines are parallel, then that means that those two angles will be supplementary. Same thing with angles 3 and 5. So, same side interior angles, that's the abbreviation for same side interior, SSI, they are supplementary. All right, so those two pairs of angles are supplementary. All right, now, there are several other relationships. Once again, A is parallel to B. It says so right there. But this time, we're talking about alternate interior angles. In this case, alternate interior angles such as 3 and 6 are congruent. Same thing with angles 5 and 4. They're also congruent to one another. So we have two pairs of congruent angles because they're alternate interior angles and these two lines are parallel. Remember, it says so right there. So, alternate interior angles, or AIA for abbreviation, are congruent. That means the congruent symbol. I'm going to tell you this right now. You need to know the relationships, and you need to know whether they're parallel or supplementary. Those are key things to this section, as well as the rest of this course. I'm telling you right now. All right. So, the third relationship we're going to talk about is corresponding angles. And once again, these two lines are parallel, as it says so right there. But we have 4 pairs of congruences. And I'll tell you, corresponding angles are congruent. So let's highlight them real quick. We'll start with angles 1 and 3, angle 1, and angle 3. Angle 2, and angle 4. Notice the greens, top left, top right, top right. 5, actually it should be 6 and 8. I highlighted wrong, so let me fix that real quick. I got a little happy with the, and then we'll make this last one purple. That'll be 5 and 7. 5 and 7. All right, there we go. Okay. So, corresponding angles are congruent. Alternate interior angles are congruent. Same side interior angles are supplementary. So let's talk next about the alternate exterior angles. Now, alternate exterior angles, as you see, angles 1 and 8, they're also congruent. So basically, 3 of the 4 relationships we talk about angle congruence. The 4th one talks about angles being supplementary, but only if these 2 lines are parallel. So alternate exterior angles are congruent. I'm telling you right now, if you don't memorize these relationships, you're going to struggle in this particular chapter. I'm promising you that. So make sure you understand these relationships. All right. Now, let's look at our example. Okay. Here's what you're given. This is kind of a logic problem. I love working these things, but here's what we know. We know that angle 3 has a measure of 68. That's all we know. It's 68 degrees. But I want to determine, just from that one angle, I want to determine all the other angles. So let's work it. And we can start anywhere we want. Let's look at angle 8. Angle 8. If you look, angle 3 and angle 8 are vertical. So angle 8, 68. The measure of angle 8 is also 68 degrees because it's vertical to angle 3. So this is also 68 degrees. And actually, I will do that in a different color. Let's make that one 60. Let's do that one in black. 68. Okay. Now, what else is 68? Well, let's look. I can tell you this. Angle 3 and angle 6 are congruent because they're alternate interior angles. So this angle is also going to be 68. So 68, it's alternate interior angle to angle 3. And then 3 and 1. They're corresponding. So those two are also going to be equal. So angle 1 has a measure of 68 because it's alternate, it is actually, I could say 2 things. And this will be the confusing part. There's so many options here. But I'll just say that it is corresponding to angle 3. There we go. We're halfway done. All we got to do is determine what the other angles are. And we can pick any missing angle here. Let's go ahead and pick, since I'm right here, angle 2. Here's what I know about angle 2. Angle 2 is supplementary to angle 1. So the supplement of angle 1 is going to be 180 minus 68, which is 112 degrees. So angle 2 is a measure of 112 because it's supplementary to angle 1. And I'm going to leave this up here. And now the thing about it is there's multiple ways to do this. So this is not the only way you can solve this. You can go about it different ways, but it's kind of a logic problem. It makes you think. And sometimes those are good things. Okay. Let's look. Angle 5. Angle 2 and angle 5 are vertical. So angle 5 also has a measure of 112 because it's vertical. Angle 2. Angle 4 corresponds with angle 2, so therefore it is also 112. So corresponding to angle 2. And then all we have left is 7. And from angle 2, it is also 112 because it's alternate exterior angle to angle 2. Now, this stuff might confuse you. So don't sweat over it too much. But I just want you to have the main idea of how this works. All right. Okay. We had some practice with this, and I've got several more examples in here, but I'm going to do one of them with you, and then I'm going to post the rest of them. I'm going to post the rest of them on. Let's get to the first example. All right. So here we go. Now for this next one, this gets real tricky, but one thing you can do. One thing you could do is you can maneuver some of these numbers around. So since 5y, I'm just going to focus on these 2 lines right here, 5y and 125. Now 5y is right there. But this is also right here. This is also 5y because these two angles are vertical. So I can rewrite it there if I want to. And if I look at 125 and 5y, they are supplementary because they're same side interior. So 125 plus 5y equals 180. And this will take some practice, by the way. It's just going to take some practice on your part. Okay, so I subtract 125. So 5y equals 55. So divide by 5. Y equals 11. All right. Now, according to this line, I can do the exact same thing with 11x. So 11x, same thing here. If I ignore this line for just a moment, I have 11x and 125. They're also same side interior angles, so I can do the same thing there. 11x plus 125 equals 180. Subtract 125. So 11x equals 55. X equals 5. All right. You're going to be saying stuff just like this throughout the chapter. I'm just telling you right now, it takes practice. Plain and simple, it takes practice. All right. I'm going to pause this video right now and we'll go part 2. I'll do the rest of these with you here in just a moment.